Good morning, ma'am. Good morning, ma'am.
Good morning.
Good morning, ma'am. Sorry for the inconvenience, ma'am. Actually, we are waiting for the participants to join.
It's okay, ma'am. It's okay.
Yeah, ma'am. And so we will start the session, ma'am. So thanks for accepting our invitation on the first call itself, ma'am. Thank you so much. Dr. Nanda sir introduced you already to me. Let me introduce you to all the participants. One second.
Thank you, ma'am.
I request Vaishnavi ma'am to read the profile of eminent speaker of today's session.
Good morning, ma'am. Good morning, ma'am.
Good morning.
I'm very happy to introduce you today, ma'am.
Thank you. Thank you. It's my pleasure also.
Okay. Dr. Urvashi T. Shukla, ma'am, is at present serving as Assistant Professor in Department of Computer Science at Banastali Vidyapeeth. She received her bachelor's degree in Electronics and Communication Engineering in the year 2009. She completed her ME in the year 2013 undergrad Gujarat Technological University on compressive sensing. Dr. Urvashi ma'am received PhD from MNIT Jaipur on hyperspectral image analysis using social spider optimization technique. She has published papers in peer-reviewed journals and international conferences. Her research interests are remote sensing, meta-heuristic optimization algorithms, medical science processing, and data mining. Welcome to welcome you today, ma'am.
Thank you. Thank you so much. So I think I can start the session.
Yes, ma'am.
Yes, ma'am. Thank you so much, ma'am, for accepting our invitation. So sincere thanks to you and for your valuable time you are spending with us with your gracious presence, ma'am. Thank you, ma'am.
Thank you. Thank you, ma'am. Uh, is it okay if I stop sharing my video, right? I think that is already done, right?
Yeah, ma'am.
Yeah, okay. Thank you. So I think my slides are visible and we can
Yes,
start.
ma'am. Yeah, ma'am. Yeah.
Okay. So a very good morning to the participants as well as the organizers. And I think that thank you for providing me this opportunity to be getting associated with you people. Uh, so I think that we can start. I think the concept which this program has brought about, it's optimization in communication engineering. So as I went through the schedule, I have gone through a lot of things in the optimization phase. Maybe the starting mechanisms, multi-objectives, single objectives, the mathematics behind that, and even the previous two lectures that you have gone through are in the same line of actions that what we are going to discuss today. Differential, even PSO, right? So what we are going to do is we are going to go into the two other categories of the meta-heuristic algorithm. But these, what you will see is they are more towards this PSO othering principle, right? So these are the swarm techniques. So in this 1.5 hour lecture, what we are going to go through is two algorithms, and both are on the swarm behavior. Okay, and we will see that how.
Number இருக்குங்க சார் அங்க சரிங்க சார் சரி ஹஸ்பண்ட்.
Okay, so in this, what we are going to carry forward is your social spider and gray wolf optimization, right? So let's begin. I'll not take much time to introduce you to these techniques, but yes, I'll spend a few seconds to make you aware like what we are discussing, why we need to discuss this. First of all, that whatever topics that you have gone through are heuristic in nature, right? Heuristic techniques actually gives you solution which is near to optimal, right? If you look at the theory or the beginning of these algorithms that came into the principles or the working arena, they were just because what your normal gradient algorithms could not find a solution to the problem. Why? Were not that It was not that they were not able to, but they took a lot of time to achieve that answer, right? So the solution was that we find a method that is giving you near optimal solution, but they should be able to give you within short interval of time. And this problem was solved using the meta-heuristic algorithms. Now you'll find that meta-heuristic algorithms are coming into a lot of categories. Even they are discrete and continuous. When I say it's discrete, it can be binary, right? And continuous, you can have a real and the whole value numbering, right? These are normally considered to be a guided way of searching a solution, right? When I say a guided way, means you will always tell your solution to move towards a better one, right? So that is why we say it's a guided approach, right? And today what we are going to discuss is only the swarm intelligence technique, right? When I say it's a swarm intelligence technique, means swarm means a group, right? So there will be actions which a group is going to decide for you, not as an individual, right? Also, as there is a word of intelligence introduced, intelligence will help you to guide the process, right? So that is why that comes in. And obviously, we are trying to solve any problem or find a solution, a potential solution, but a optimal one, right? So you cannot say pinpointedly, okay, this is the perfect solution that you get. Or I cannot say that if 2 or 3 people are doing the same problem and each one of you are getting a solution, like for example, I'm getting 10, someone is getting 10.79, someone is getting 10.59. So I cannot say they all or their approaches are wrong, they all are right, and they're giving me a solution which is near to the expected one, right? Okay, so let's begin with the first one. The first one that we're going to discuss today is a social spider algorithm, right? Now, see, the name is very well expressing itself. It is social, right? So when anyone, in humans also, when we are social, right? So what do? We meet other people, we talk to other people, we have a normal life sort, right? So same, the spider is also going to have this sort of behavior, okay? This concept or this algorithm was introduced by Cruves and Eric in 2014. They came up with this ideology because they saw this behavior in the jungles of the Africa. Okay, and here what the principle is going to be very simple. I'm going to divide my whole population, right? When I say population swarm, so I'll take the example that for example we'll take example like of sin x, right? So if my problem is to get the solution for sin x, right? And you can take a range of from between to 0 to pi, okay? So I want my problem that I want to maximize, find the value at which my sine wave gets its maximum value. So we know it's pi by 2, that you get a 1, right? Sorry, pi by 4, right? So what will be my potential solutions of the population? Population will be all the values of x between 0 to pi, right? So you can take all the values of x between 0 to pi, right? Inclusive bracket where both of them can also be a solution, right? This is the problem, right? So first step will be to decide how many population I want or how many spiders I want. So I will tell, let me have 10 spiders, okay? I'm going to have 10 spiders. That means 10 x values. Take them randomly, right? Because the first rule of any of the meta heuristic says that, okay, you can initialize the population randomly, right? Not always, but mostly, right? So you can have that x value between 0 to pi. Okay, so for example, the 10 people who are there, someone has taken 0.5, 0.7, 0.10, 1.4 or something like that. Okay, so all 10 values are with me. Right? Now the next step that comes is, whenever it's a swarm, right? So each one has to play its role, right? If you see the birds also moving, you might have seen the birds moving. They move always either in this fashion or this fashion, right? So there is a curvature, right? No one moves in a single line, like the ants move differently, right? So there is always a movement that is peculiar to that particular species, right? So same way, spiders also have some peculiar behavior. Here the peculiar behavior is that we are going to have three agents, right? I think that you might have gone through till now. There is something like EE balance always in any of the heuristic algorithms. Now, what is an EE balance? EE balance says has to be someone who is going to explore for you and someone who is going to exploit for you, right? Now, why do you need a balance? Balance is needed because, for example, if there is a room that I'm in, I want to find a safety pin, maybe a pin or maybe a button or something like that in that room. I have two options, right? I jump and cover each corner of the room, right? And I might get that button or the pin. That is exploring the whole space to find a solution. That's your button. Next way can be, if I don't get the answer in my exploring, right, of covering that whole space, that means there is the button which is still there in that space, but you have skipped that, right? You skipped the solution on the search space. So I exploit, right? So what will I do? I will go slowly and search at every space with minute detailing, right? So that is exploiting. Same logic comes in your these kinds of algorithms, right? So any of the algorithm will always tell you that these are the agents who is going to explore for you. These are the agents who is going to do exploiting for you. So here also in Social Spider, we have three groups that are working for us. Okay. So the first group is the females, right? And the second is the group of male, right? So, the spiders are very opposite to humans. They have a society which is female dominated. Okay, so you'll find that 60% of the spider population is full of females only. There are other theories also, like that after mating, or sometimes if the food scarcity is there, then males are actually eaten up by females for the survival. Okay, so that theories are also there. So that in that case you will find that only remaining 30 to 20% population of the total is considered to be as male. In that also male, they have two categories, dominated males and non-dominated males. Okay, so they bifurcate males into two categories: dominant males and non-dominant males. I'll give you a simple example. Why do we do, and why it is there? In our society also, there is a sort of these kinds of figures you can find. There are few males, you might come across. Okay, they have money, they have attractions like Hrithik Roshan or something like that. And there are the other males like non-dominated population, where they live a normal life, right? They might be having not so much of money, not so much of fame or something like that, right? So there is always a sort of bifurcation in that sense. Here also the same logic applies, but here the bifurcation is done based on the weight of the spider, right? So they say that if the spider is having more weight, he comes into the category of the dominant males, right? And dominant males get all the attention in the society, right? That is how it is guided. So this is a simple graphical representation to tell you that, okay, what is the population, how it goes. So you can see that you have a dominant male group, right? Non-dominant male group and the female group, okay? Now, the next thing that we also do is the communication, right? Because communication is how you get your information flow, right? So here, three kinds of communications are there, right? First communication is the best has to communicate. Now we know that this is guided process, right? So best has to tell others. We also do something like this, right? We look at the people who we find a pioneer more, maybe like Vivekanand or Gandhi ji or something like. These are the people who guide our sort of journey, right? Maybe any of your owns. Same way, the best person here in the spider is going to guide your process. Right? So he will tell others that what is the information that I need to pass on to search the solution. Right? So in the example of sin x, whoever values of x are fetching you a value which is like 0.8, 0.7, 1, nearby 1, are going to be considered as the best solutions. Okay, their positions, right? Then the second communication, which is there, this is the best communication from the best ones. So now if you see this, the factor which is added in the communication is you have a weight, right? Weight of the person who is communicating to that, right? And then there is a exponential decay with respect to the distance. Now the reason for this is because you are communicating on the web, right? Web actually is made of there's a sort of material, it's an elastic material which comes from the saliva, and when you tap that, it actually generates an oscillatory motion, right? So it is an oscillatory motion on the tap, and it goes and decays over the time with the distance, right? So that is the reason why factor e raised to minus d, distance difference is there, and as the tap, the first surge obviously will be more for a person who is having more weight, right? So that is why it is multiplied with a weight factor, right? Same way, the second communication is between a person who is best but nearest to me, right? For example, maybe my role model in my family, for me, the world is small, right? So for me, my role model, maybe my brother, my father or something. So the person who is best around me and nearest to me, right? So he's also going to guide my life, right? Same way, if there are 10 solutions and 4 solutions are in the corner, so for that corner, the best solution will be who is reaching towards the major solution, right? And the last is the communication with the females. Now, the reason for this communication with females is because you have to generate new solutions, right? For example, I started with the 10 values of X. Now I need more values of X because it might be possible that in that 10 values of X, I never got the value which was nearer to 1. So I need more solutions, right? How will you get more solutions? By other modes of generating the new solutions. One of the mode of generating the new solution is considered to be mating process. Mating is considered to be there, right? So for that you need females. So the communication with females is obviously important. Right? Now, here the question comes, okay, let us complete this and then we'll consider this. Now comes the movement, right? Now what is the movement? The movement will be actually the movement of the solution from 0 to towards 1, right? That means you have to get the values of X in with respect to sin X to move from 0 to 1, right? So how will they move? They will move when your factors are moving, right? Your solution space is moving. That solution space movement is considered in spider with help of the agent movements, right? So the first movement that is there because of the female. Now, this is very normal that females are very moody, right? So here also the same logic applies. The females are then always the females, right? So in this case, what happens is the females, because of their mood, either they are always in communication with the other people in the group or they shun away and stay away. Okay? So this is what kind of behavior is observed in their life cycle. So that has been brought mathematically by taking that either solution space moves forward direction or the backward direction, right? In the pictorial format, right? Or vector format. So that movement is guided by the PF factor, right? So that is one thing. You select randomly PF factor because certain the behavior or the mood of the females cannot be on the exact scale, right? So that is why. Now, if you see this equation, there are many factors that you have already studied. Okay. The first factor, if you see, I obviously consider the person whose movement is to be considered. So let us consider that we are talking about the first value of X, right? So what am I adding to that? I'm adding the
Excuse me, ma'am.
communication with the local best. Yeah.
Ma'am, your first slide is only visible, ma'am. The slides is not changing.
Okay.
Share your entire screen, ma'am. Yeah, now it's
Okay. I think, but I think okay. Just a second. Hold on. Is it
okay.
visible now, ma'am?
Now it's visible,
Is
ma'am.
the change
Female
visible?
cooperate. Change again,
Okay. Yeah.
it's not visible.
Is it visible now?
Only that female cooperative operators are visible, ma'am.
So maybe.
Ma'am, you share entire screen.
Yeah. Okay. Okay. I will do that. Is it visible, ma'am?
Yeah, ma'am.
The change is visible. That has to be the more important one.
Yeah, ma'am.
Okay. Shall I continue?
Yes, ma'am. Sure.
Okay. So sorry for the inconvenience at my side. Okay, so I think that we can continue. Now I was talking about the movement, right? So if you see this movement, this is the person whom we are considering. Then the factor which is added to is the local best, right? So you get the information from the local person and you add the information. Then you get the information from the global best, you add the information, and then you have a certain random factor. Um, Now, global best and local best, yes, we need the information because it's a guided search. We always want to move towards the maximum or our goal. This random factor is always added. Why? Because normally what happens, if there is a multi-model problem, right? When I say it's a multi-model, means you have continuous peaks, right? Maxima and minima peaks. It might happen that your solution might get stuck into something known as the local minima problem, right? So for that, you need a certain random value to be associated with the change so that if it gets stuck into that local minima problem, the solution will be brought outside, right? So this is the reason why always a certain random values are added at the end of these movements. And this behavior you will see till the all the agents in the all the algorithms normally. Okay. Then comes your change of the movement with respect to dominant males, right? So here what you see is the behavior of the dominant male is guided always with respect to the female perspective, right? Because dominant males are the population that is for mating, right? Okay, so in that case, you see that they have their original position, and the second guiding population will be the female movement, and the last, the random factor, as usual, for the introduction, right? And the third movement is your non-dominated movement, right? So before going to the non-dominant movement, I will say that explorer part, right? Exploring part of the algorithm is taken care by the females and the dominant males, right? So now we want some agents whose movement is going to be explorative. So for that case, you have the non-dominant movement. So if you see that their equation, they are having the movement which is guided by the weighted mean of the dominant male. So when the value is something like a weighted mean, it's a very small value. That means their change in movement is very small. So you are actually asking them that please go slowly, increase your value slowly, and so you might find a solution. So they are doing the explorative part for your algorithm, right? So I think there is a balance. Two agents are doing exploring and one agent is doing the exploiting part. Next come is how do you find a new solution in the existing population. So for finding the new population, we need a mating process, right? So here in social spider, they have used the tournament selection, right? So they have a population. Here what happens is a male comes into the contact. It may be the mating with one male, two male, okay, and they find a new solution, or a small baby spider comes into the picture. The baby spider is introduced into the swarm only in the case if he is a potential solution better than the existing pool, right? That means if you have a new solution that is generated is zero point 0.3, and all the solutions which are existing in the pool are greater than zero point 0.3, then we discard that new solution also, right? So anything which is better than the existing, you are in, else we discard the solution, right? So the same procedure is followed in here also, right? So there. Now, what I could say, that what advantages that you come across, or the disadvantage for applying social spider, are like, it's easy to understand, right? You can implement easily. You have a PSO resemblance. The success that PSO has witnessed, we all know. We are quite acquainted with PSO working, right? There is a good balance of exploration and exploiting that is there seen. Achievable optimal solution has been found both in the continuous and discrete in case of social spider. But some of the disadvantages of this algorithm are there, that is time complexity. Why I would like to tell you is that because see, if you take that my population size will be 20, right? So 20 as social spider, again dividing into 3 agents, will not give you much space, right? Also, it won't bring that balance, right? So for that you need a huge population size. Approximately 50 around is required minimum, right, for this algorithm to work. So if you're trying with 50 population size, and then you are doing all these steps for any of the solution, you will have to have some space for time complexity, right? I could not say that social spider is applicable to all problem, right? So you have to actually mine out which problems can be really solved by this algorithm. And also, as I have been working in this algorithm, so what I feel is that the role of the non-dominant males can be still more mathematically improved. It is quite underrated, and certain features still can be added so that more application areas can be opened, right? So with this we end the first algorithm discussion. If you want, we can take a 5 minutes question session, or otherwise I can continue with the next algorithm.
Participants, anybody are having any doubts, you can unmute and talk.
Okay, I see.
Yeah, ma'am, you can proceed, ma'am.
Okay, so I'll continue rather than taking
Yeah,
your
ma'am.
time. Yeah,
Yes.
okay. So the next algorithm is the gray wolf optimization. Now, this is again a swarm technique only. The gray wolf is considered, it's a hierarchy based, right? So there in the social spider, what we saw was that you divided the population based on certain characteristics, right? Being female or male or weight, right? So here what we do is we take a hierarchy, right? So there are the people, there are certain wolves who is going to be the topmost pack, then you will follow on with the next, and so on. This concept, this algorithm was proposed by Mirzali in 2014, right? So he considered the wolves as apex of predators, right? So wolf are considered to be like the most species that they hunt, and they have a very great hunting skills, right? And they are the top in the food chain also, right? So they have a lot of skills with them, and that is how it is there. Normally what they have found is, behavior of wolf, they live in a group, right? Because as it is a swarm or a group pack techniques, and on an average you have one group with something around 5 to 12 members on an average, right? So, and they have a very strict social dominant hierarchy. So there are three terms that has been continuously introduced. A strict means they all follow to and adhere to rules. Social, because they are living in group, they are not working as an individual. And again, dominant, because there will be certain wolves who are having higher authority compared to the other wolves that are residing in the same colony. So this is what is the social hierarchy that you will find in wolf techniques. So there is something like alpha, beta, delta, and omega. Same as what we saw in your social spider, like female, male, they have 4 categories. That is your alpha, beta, delta, and omega. So we'll study characteristics of each group, and we'll connect to how the solution can be found in the same case. Now, the first level is your alpha, right? Alpha here are considered to be the dominant wolf. They have all the responsibilities of hunting, and they're considered to be as leaders, right? And so they will be followed by the other wolves in that group, right? So actually what you can say is that they are the global solution, in the same aspect that we went for Sinex. So if there is some solution which is coming as zero point 0.8, zero point 0.9, so those solutions who are giving you 0.8 and 0.9, their corresponding X value will become the alpha wolves, right? So they will be the solution who will help other falling solutions also to reach further ahead, right? So this is how the wolf are doing, right? So in that leaders, the alpha can be male as well as female. They have wholesome responsibilities of like making decision when to hunt, how many people will be there in the hunting, what is the time that we need to reciprocate, what is the time that we need to go for hunting, how many hunting are to be taken in today's time, right? So all those decisions that will be taken by these pack, okay, this group, I would say. Okay, they are in a dictatorship position, and all have to follow them. Okay. Then comes your next level is your beta group. Beta are the subordinate wolves. Now, why would I say subordinate wolves? Because this group actually will take the decisions um, on the behalf, right? On the behalf of the alpha group. Now, what is happening here is that, for example, if there is some alpha wolves are injured, right? Or some alpha wolves have become ill. So who will be there? Who will be aiding to them? The next, as it is a hierarchy. So if the king is not present, who will be the other king? Whoever is the member of that family, right? So that is how the hierarchy is passed on. That same way here, the beta group has all the they are the best people who can be taken ahead to become the alpha wolf, and they help the alpha to, like, for marking the density, marking your area of work, or how would you go ahead. And they will be directing, they take the position of the alpha, right? And they also have to communicate whatever the decision of the alpha to down the lane, right? So they have to communicate to delta as well as omega group, to take the decisions, help them. Okay, you have to move in this area, you cannot go here. So this all will be taken care by the beta. Third is the delta, right? Now if you see that the third level are also is also sometimes called as subordinates, but their work is divided into certain categories, right? So normally there are different groups that will be there in your delta, right? and they always have to work as per the directions given by the upper groups, and they will be doing that work and communicating back to that hierarchy like alpha and beta, but they will be more dominated to the omega, obviously, right? So what are the responsibilities that is given to the delta are like, for example, the first is scouting, right? So what is a scouting? They have to watch the boundaries, they have to safeguard the territories, right? There is a, if there's some danger or there's some warning values, they inform to the alpha and beta group. So the scouts are always from the delta. Then the celestial wolves. Celestial wolves are always responsible for protecting the pack, right? For example, we also have soldiers. So that is how the celestials are also working in the same direction. Then there are elderly suggestions that comes. So elderly people who give the experience, okay, today's weather maybe, or some problem, health issues, or hunting problem, food in the harsh environmental conditions. So that is also coming from the delta. There are hunters. Hunters will be always, hunters are also coming from this delta group. So hunters will be responsible to help uh, hunting alpha and beta, right? Because if the preys are more, they might need more people to hunt for them. And so how it hunters go. The last is the responsibilities of the caretaker. Caretaker comes into the picture not only for the weak, ill, wounded, but also for the small wolves who are there. So they have to be taken care when the other wolves are, the alpha are at hunting positions, then there has to be some wolves who take care at the back end. So these are the caretakers. So with this, all the five duties that are there, that is consigning only to the delta group, right? So till now we have seen three groups, that is the alpha, mostly the top of the hierarchy. Then second is your beta, and the third delta, and the last that we'll be talking about is the omega. Now, omega are considered to be as scapegoats in the pack. So they do not take any decisions on themselves. They do not have any right in the their wolf pack, right? So their role is something that they always have to work as per the down the information. And you will see that, you know, they are not the role that they play is not considered to be as important as an individual, right? And they are also allowed to eat only after the upper hierarchy has been completing with their food, right? So this is the narrowing down. Now again, we need to find who is going to be the explorer part and who is going to be the exploiting part. So explorer part here will be played by your alpha and the beta group, right? Because they are the most active people in the group, right? So their movement is very fast as compared to the delta and the omega, which is paying up. So here the exploring part is burdened on the alpha and the beta, and the exploiting part is taken care of by the delta and omega. Why? Because their role is low, so their movement is less. So finding a solution in the space slowly will be taken care by these two groups, right? Now the social hierarchy, right? So whoever is the fittest solution, or whoever is nearer to the optimal solution, will become the alpha. Then so on. That means you will sort your population, right? You will always sort the population based on the fitness. um, Whoever is the fittest wolf will become the top of the hierarchy. So whoever is the fittest solution in your case for finding an optimal solution will become the top solution, right? For example, sine x value of 1.13 will give you uh, pi by 4, right? So pi by 6 is giving you some nearer answer. So that value will become the top of the population that you have taken, right? And then you keep on ascending order, right? So you keep on taking up one by one the solution, and you consider the whole solution. The rest, whichever, for example, you have taken 20 solutions, then you sort them, right? So last solutions, right? The first, second, and third, that will become alpha, beta, and delta, and the rest will play the role of the omega, right? Now, the hunting, right? So obviously, they in your social spider, we talked about the movement, right? So we talked about the movement in the spider web, right? So here the movement is considered on the plane, right? Because your movement is always for the hunting, right? So their main action is hunting. So they have formulated that, okay, our hunting will be based on certain formulas, right? So let us see what is the mathematical formulation done for hunting the prey. Right? So what do? Is they do an encycling process, right? So obviously, if there is some, it as it is seen in the pictures, also it's visible. If there is some animal which they want to hunt for, so they'll make a group around it, and they will try to, create a fear in the other animal that you're now going to be eaten or you're there. So that's an encircling process that is done. So here the behavior of encircling that is there. So what you can see is C into XP minus XT, right? So XP is the position of the prey, right? So with that respect to the position of each member is going to be calculated. So how much far you are from your prey, right? So that is a distance factor, right? And then because you have to either move towards the prey or away from the prey, right? Obviously there can be only two actions. Either I go for the hunting, either I move away from the hunting, right? So that is why the update in the position is with respect to the XP, right? The position of the prey, and where the position of the prey is minus A into D. Now there are certain factors like C and A. So these are the constants who is going to guide your process, right? So these are the values that you have to take, or sometimes we also take them as a tuning parameters, what you say. So these parameters have to be tuned in, right? So here it's there. So these parameters are given certain names. Okay. So for any of the current iteration, right? So you have your coefficient vectors, right? XP, as I told you, it's a position vector of the prey, and X is the position of the wolf, right? So they have calculated your coefficient vectors, that is A and C, using a formula, right? So A is considered as 2 into R1 minus A. Again, all random positions are there. The reasons for taking these random value is because we don't know which individual wolf is thinking what, right? So how would you take the decisions of the movement in the mathematical formulation? So the best way to emulate them into the real mathematical formulation is using the random values. So that is why these random coefficients are taken, right? But obviously when you apply them, right, for any of the applications, the values will has to be tuned as per the application, right? For example, if you're using in certain optimization problem of mechanical, right, for some design parameters. Second is for you're using for some seating arrangements, then the values of the A and C, which are taken for both the applications, can never be same, right? Now the encircling process, right? So as we know that hunting is obviously the process which is guided by the alpha, right? Now both alpha is the person who is there in the hunting process, but the two next in the hierarchy, beta and delta, their contribution to the hunting is manifested that, okay, they are not always present there, but depending on the demand and the situation, either of them can come into the picture. So here the next thing that comes is we have done the mathematical process of our hunting process, and we know that who are the people who are taking participating in that, and we have also updated the solution as per the moment. So this is the mathematically what you can see here is now the equation initially was shown with respect to was a normal equation where you have the communication between prey and the wolf. The wolf can be from any of the uh, domain, that is, he can be alpha, beta, and omega. So what they have done is they have taken the role of all the three, right? So d alpha, d beta, and d delta. That means distance of the prey with respect to the alpha position, beta wolf position, and delta wolf position. And then a cumulative decision of the distance is taken. So which wolf will be moving by which, how much distance is taken care, right? So here what is shown is this is your prey, a radius has been taken, that is r, and the movement, the complete, this is a this is your wolf whose movement has to be judged, right? So he will take his movement will be affected by alpha, the beta, and the delta, right? So what are we taking? We're taking the same equations, right? But now it's an addition of the three and given to the prey. So this is the complete algorithm of your gray wolf optimization, right? So here also we'll do the step one. The what is the normally the step one that is done in any of the algorithm is population, or the population and parameter initialization. So who are the first is the size of the population. So I will take 50, 20, 30, we can say. Here the normally the value of wolf that you will find in the research area is something about 20 to 30 in the range. Okay. Then you have your parameters. So who are the parameters that you need to take care? You have to take care of the A and C, right? Because that A and C were the random movement that guided the hunting process. And the third is the stopping criteria. I think that we haven't discussed in both of them. Uh, what is the stopping criteria means, right? For example, I'm doing the sin x problem. Okay. So what is your, what are you looking forward for? We are looking forward for a value which is maximum, and I want the value to be 1, right? So what can be my stopping criteria? I can stop when I reach 1, right? That is one thing. For example, after I saw that, I reached 1 at 100 iterations, right? But before that also at 99, 97, 98 also it was already 100. So I found that, okay, from 50 only it is 1, right? So the next thing can be, I can take that maximum iterations. So I'll stop the max after maximum iteration of 1, of 50, right? So this can be the stopping criteria. Other can be the change in the solution, right? You can obviously witness the change that is coming in the solution. For example, as I told you that after 50 there is no change, you are getting 1 only. So what you can see is, you can have a window size that, okay, after 20 iterations, if there is no change in the optimal value, we can stop the algorithm, right? So that is also there. So there are many criteria which has come about, and the stopping criteria can be decided by the person who is formulating the problem, right? Then is that you start with the first generation. Normally when we talk about this, we talk about the generations, right? So we start with the first population, right? You find the fittest solution, right? Why? Because you have to bifurcate population into alpha, beta, delta, and omega. So how are you doing that? That is based on the hierarchy, and hierarchy is guided by whom? The fittest one. Who is the fittest? The solution which is giving you the best answer, right? So you take your fitness function, right? The fitness function, the objective function, whatever you're looking forward for. For example, if you're looking forward the application of image, then your fitness function will be the correlation between the pixel. If you're looking application of any design parameter, then you're looking for a design of a screwdriver with maximum rotations. So you fit in that solution. Okay, is this size is giving you maximum rotations? If no, then you're not considered as a solution, right? So this is how we do the fitness solution as per the application, right? Then comes your bifurcation. You divide those solutions as alpha, beta, and delta, right? Then what is the act here? Here ACT is of encircling, right? So you keep on doing that encircling, right? So that is what is coming in your solution update, the repeat rule. So you keep that encircling, and as the parameters are there, parameters positions will be updated. Once your positions get updated, obviously your fitness is going to be changing. So for that fitness that you have with you, you again make uh, a solution listing. Okay, after the change, what is the fitness, right? So then whichever the population is giving you fittest solution, you repeat for the next iteration. Here also you have many methods. See, we have many methods for finding who is the best solution. There are many methods of population replacement, right? For if you'll see that there are many algorithms who consider the population size to be constant over the time, right? So that means you started with 50, you will always be 50 only. You keep on replacing the bad solutions, right, based on the fitness. There are certain methods where population size can be increased, right? So if you're increasing the population size, it's good because you're bringing in new solution space. But with that, you're increasing the time complexity. Okay? So there's always a lot of things that that the designer has to think, right? Before jumping into any of the working solution, right? So this is how the continuous algorithm is taken care, and whoever is the best solution, that always will be given from the alpha group, right? Because he is the peak of that pack. Now, what are the advantage of this algorithm, right? The gray wolf. First, what I felt is it's a very simple. There is no more mathematical equations. It's very simple. There are only equations of the hunting, and the hunting equations are only the distance minusing. That means you take the simple distance formula, right? So it's the simple structure is very simple. Then because as the structure is simple, if you're applying it for multi-variable or multi-objective sense, right, then the storage requirement is very less because the variables are less to store. Convergence is faster, right? And also uh, if you see compared to the social spider, there is not much things to be done in the writer because their communication is not mathematically modeled. They do not have any other parameters to be introduced in. There is no mating process. But if you see the social spider, there is communication, mating process, even the movement, right? So there's a lot of things that are involved there. Decision variables are less, yes, because you only have to think about two, that is A and C, the coordinated movements, right? And they have to be adjusted. If you make it, the wolf is you working for your application, right? Now, what I would like to spend some few time is on the research gap, what I have always felt, because um, if you'll see that today, a lot of publications are coming in this area, but there's a lot of work at present to be done, which is being done is on multi-objective and multi-variable concept, right? So what as I have felt is that pick any of the algorithm, right? Maybe a spider or a fish one. There are frogs, there are monkeys. There are lot of like it's an endless list, right? So what as I being a researcher in this field, what I feel is what is the reason that there is not so much popularity that what GA and PSO gained, right? Why other algorithms are not making to that? The reason is we are not sure that what is the theoretical foundation or that is there behind it, right? We studied their behavior, we formulated a something mathematically called their movements, and we tried to solve a problem. If you're able to solve, it's good work and you find it. But if you're not able to, we look for another algorithm, right? So you will see that there is something like free lunch theorem. So you cannot say that my algorithm is going to be the jack card which will work for any application, right? So there is a lot of theoretical background which really needs to be worked upon. that, why these algorithms are working, or is it necessary to bringing such algorithms actually, right? Also, people talk about exploring and exploitation as in their algorithm, but there is no formal definition, or what you will find is how it is implemented, what is the level, the depth, or has it been satisfied by that agent or by that group that you're talking about. So it's a little of dilemma, right? So we obviously need really to find out that each of the algorithm which is considered is contributing a well balanced, or I would say a ratio of between these two parameters, the exploration and exploitation, right? Also, the next challenge that has come across is how would you compare, right? You will see a lot of paper that comes into the picture which says, okay, we have compared PSO, we have compared GA, we have compared Wolf algorithm for the same application. But is it a fair comparison? Like, because what you take is, you might take the same platform, right? You might take the same number of population size, but that's not going to give a solution. For example, in GA, you can do the same problem solution with 20 chromosomes, but in case of SSO, it won't happen. You take 20 spiders, that won't give you an answer. You have to take 50 and above that to get the solution. So is it better to invest 30 more and get a solution, or rather sustain with that 20 and in GA and work about, right? So these are there, right? Then there is a large scale optimization problems which have never been answered, right? So there's a lot of potential area in the positive side also that you can work here. We also need a lot of methodology that can look forward for, how, if you look at the literature, each step, like for example, I'll take initialization, right? So in initialization, you have a lot of techniques. Now people are coming with more and more techniques, like quantified sampling, surrogate theories. Then they take fuzzy definitions for initialization, right? Rather than picking up randomly, and they say that, okay, we did this because the initial solution was not random, so our convergence is better, right? Yes, accepted, that is true. But is it that your initialization method is going to be fitted into all others? No, we don't have an answer. Second is, how is the mating process? Certain people do it using crossover as NGA, certain are having tournament selection, best selection, other, and this and that. Even selection techniques are also, lot of selections or techniques have come across. So what is the last, at someone working in this field will really feel that, okay, I might have tried this method, I might have got this answer, right? So there's a lot of thing there. And the last thing is that, can really, if the solutions are working good, can other techniques be brought about so that we can have less time consumption? For example, parallel techniques, GPU techniques, uh, right? What is there? Multitasking, multi-threading, or all these techniques can actually be brought about, and we can find a good solution with less time complexity and memory utilization. So this is what I have found, and I would like to thank the participants as well as the organization team for giving me this opportunity. And the last thing from my side is questions or your query time. It would be great to have them. So thank you from my side.
Thank you, ma'am. Participants, anybody are having any doubts, you can unmute and ask. Ma'am, 1 second, can you please switch on your camera so that we can take...
Yes, ma'am. Sure. Yeah, hello.
Yeah.
So all your questions are welcomed. I hope that,
Anybody having any questions? Ma'am, I have one question, ma'am. When I
Yeah,
did my
sure, ma'am.
PhD, I used this gray wolf optimization. So nowadays, the same channel estimation and all, they are doing with the different combination, hybrid combinations of the different algorithms, ma'am. So again, now I feel that there are so many other new techniques are upcoming. So how to decide which algorithm is best for our problem, ma'am?
Ma'am, I think that this is the most difficult question that to come across, because if you'll see that for same thing happened for me also, that I solved the problem of image. My problem was image. So when I started, I
Yeah.
solved it using Social Spider. Right today, if you'll see that there are a lot of publications that has come. Okay, that our algorithm is also working. Our algorithm. So what
Yes.
I feel is you just look into the literature first, right? What is the people telling you, right? For example, if the GA is working best, right, for channel estimation, you have
Yeah.
also applied gray wolf. So at present, you just try to thoroughly go through that literature. Okay, some people are telling it, and let us find the solution from that only. Because if someone is saying that, okay, rather than gray wolf genetic is algorithm is working, then we have to first verify what is his working conditions, and what are the conditions in which his algorithm is making good answers, right?
Yeah.
It is completely going to differ, because we are not working on the same system, we are not working on the same working conditions, even our parameters are not same, ma'am, right?
Yes, ma'am.
So you will have to thoroughly go through the literature, what that person is saying, that for him zero point 0.7 is giving a good answer. Then you have to find out that why 0.7 is giving a good answer for him and why not for you.
Correct, correct.
Right. So
Nowadays,
you
upcoming
go through that.
hybrid algorithms. Hybrid algorithms are also coming into picture, ma'am.
Yes, hybrid are also coming. The reason for bringing in hybrid is very simple. For example, I'll take my example only. We can take Grey Wolf also. In Grey Wolf, what they are doing, they are only finding the distance, simple distance, right? You find the distance using another algorithm, any of the hybridization, right? But
Yeah.
you just try to see the two main points in that. The first is that when you're doing hybridization, is your solution moving in the space, right? For example, what happens
Yes.
sometimes that when we try to mix two algorithms, rather than bringing in the solution, we take the solution out,
Correct.
right?
Yes.
For example, if you're doing channel estimation, weight estimation, the weight was supposed to be there within the range of 0 to 1, but your answer is going out of the 1, because you have
Uh,
mixed two algorithms. Even your initializations you have done wrong, or something has happened. So what I would say is, being at this position, I cannot say that okay, they are wrong or mine is best. But when it's a process of judging or applying into the application, then you really need to spend some time with these algorithms and find out, okay, if there is some potentially a good papers are there, if even good algorithms are there, you can try them once and check into certain parameters that if they are fitting, it might give you the answer.
correct. Yeah, sure, sure. Thank you, ma'am. Ma'am, I
Okay.
wholeheartedly thank you for accepting our invitation and I express my gratitude to you, ma'am. Thank you so much. And you explained elaborately, you explained about the social spider algorithm and also the gray wolf optimization. And you explained in a neat manner what is the principle for survival of the fittest. So, for all these biological evolutions. So, thank you so much, ma'am. Thank you for being with us in this MDP. Thank you, ma'am.
Okay, well, welcome.
We'll be in touch with you in our future events also. Thank you, ma'am.
Sure, ma'am. Thank you. Always welcome,
Thank,
ma'am. Have a nice
yeah.
day, and thank you
Thank you, ma'am.
participants also. Yeah, and a
Yeah.
bye from my side, ma'am. Have a
Yeah,
nice.
ma'am.
Thank you.